Bismillahir Rahmanir Rahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the solutions of S1 variant 5.2 of March 2021. And for this, I am using the work of an outstanding and one of my best student, Miss Mahroush of class 2022, the Lyceum. All these instructions are very important, especially this last one. Give non-exact numerical answers correct to three significant figures. Must follow all these instructions. An important advice. Be kind and be humble. Two important tips to solve the paper in a good way. Number one, read questions carefully. Number two, avoid careless mistakes. Question number one. A fair spinner with 5 sides numbered 1, 2, 3, 4, 5 is spun repeatedly. The score on each spin is the number on the side on which the spinner lands. Since the spinner is fair, therefore the probability of each and every number is same, which is 1 upon 5. Part A. Find the probability that a score of 3, which is the requirement, is obtained for the first time on the 8th spin. For the first time on the 8th spin, this statement means this situation is of geometric distribution with P1 upon 5. And this is the formula for the 8th spin. Q power 7 times P. Q is 4 upon 5 and P is 1 upon 5. So you need to give your answer up to 3 significant figures. Part B. Find the probability that fewer than 6 spins are required to obtain a score of 3 for the first time. This is the formula for fewer than 6. 1 minus Q power 5. So 1 minus 4 upon 5 to the power 5. Give your answer up to 3 significant figures. You must be good at the formulas of geometric distribution. Question number 2. Georgie has a red scarf, a blue scarf, and a yellow scarf. Red, blue, and yellow. Each day she wears exactly one of these scarves. The probabilities for the three colors are 0.2, 0.45, and 0.35 respectively. When she wears a red scarf, she always wears a hat. Always means certain, means probability is 1 for head. When she wears a blue scarf, she wears a hat with probability 0.4. Whereas when she wears a yellow scarf, she wears a hat with probability 0.3. Part A. Find the probability that on a randomly chosen day she wears a hat. So we need this probability, and this probability. This answer is 0.2. This is 0.45 times 0.4. This is 0.35 times 0.3. So the final answer is 0.485 up to 3 significant figures. Part B. Find the probability that on a randomly chosen day she wears a yellow scarf given that she does not wear a hat. Given that she does not wear a hat, this means this option or this option or this option. All these three options must be in denominator. And this option must be in numerator. Means yellow scarf and no hat. So this should be in numerator and all these three should be in denominator. And give your answer up to 3 significant figures. Question number 3. The time spent by shoppers in a large shopping center has normal distribution with mean 96 and standard deviation 18. Part A. Find the probability that a shopper chosen at random spends between 85 and 100 minutes in the shopping center. So we need this probability. X lies between 85 and 100. First, we need to convert this statement from x into z with the help of this formula, x minus mu over sigma. So x is 85, mu is 96, sigma is 18. X is 100, mu is 96, and sigma is 18. So when you will solve this, this is the way to solve this. You will get this result first. This is plus number, so this should be 5. This is negative, so this should be 1 minus 5. When you will simplify this equation, you will get this equation. And you know how to find the values of phi. And give your answer up to 3 significant figures. And this is the sketch for z. And we need this area, which is this 0.317. This is the question of inverse normal distribution. 88% of shoppers spend more time, more than T minutes in the shopping center. This information is given. So we need to shade this area with respect to this sign of inequality. Since we have greater sign, therefore, we will shade this area from upper tail towards lower tail, which is here, 0.88. And its corresponding z value is this, minus 1.175. So you need to equate this thing to minus 1.175, which is here. Therefore, T is 74.9. You must be good at this shading. We shaded this area with respect to this sign of inequality. Whenever we have greater sign, we shade area from upper tail towards lower tail. Question number 4. The random variable x takes the values 1, 2, 3, 4 only. The probability that x takes the value x is this. So this means this thing. This statement means this equation. X takes this probability. For example, if we have x2, then 2 is here. You need to put 2 here, and when you will simplify this with x2, you will get 6k, which is here. So you can easily get the probabilities of these numbers with the help of this formula, which is here. 1 is 4k, probability of 2 is 6k, probability of 3 is 6k, and probability of 4 is 4k. So, and you know the total probability is always 1. So when you will solve this equation, you can get the value of k, which is 0.05. Now we need variance. We need to show variance, and for that we first need to work for mean. And you know how to get the mean. Mean is simple. Mean is the sum of product of these numbers. So k is 0.05, therefore this is mean, 2.5. The sum of product of these numbers is 2.5. And in variance, we first square this number, and then we multiply the square of 1 with this probability. 2 square and multiply by probability of 2. 3 square multiplied by probability of 3, so on. So, and minus square of mean. Here is the formula of variance. Must give your answer up to 3 significant figures. Next question, number 5. A driver records the distance traveled in each of 150 journeys. These distances correct to the nearest kilometer are summarized in the following table. 0 to 4, 5 to 10, these are the intervals, these are the frequencies. First you need to make the class boundaries. And make sure you write 0 as it is, because distance is a scalar quantity and it can never be negative. So you cannot write minus 0.5 for this 0. You just need to copy 0 as it is. This is 4.5, this is 4.5, 10.5, and so on. These are the mid values. Mid values, always find mid values from the class boundaries. The average of class boundaries will give you mid values. We will need mid values for the calculation of mean later in this question. Draw a cumulative frequency graph. This 12 is here. 12 plus 16 is 28. 28 plus 32 is 60. 60 plus 66, 126. 126 plus 20, 146 plus 4, 150. Same. And this 12 is for this class boundary, 4.5, 12. And for this, always 0. I mean, the cumulative frequency for the lower class boundary of first class is always 0. You just need to plot these things, 0, 0, 4.5, 12, 10.5, 28, 20.5, 60, and so on. And make sure you must label both the x's. This is distance in kilometer, cumulative frequency. Part B. For 30% of these journeys, the distance traveled is d kilometer or more. Or you can say, for 70% of these journeys, the distance traveled is d kilometer or less. So 70% of 150 is 105. This is 105. and this distance is required, which is 26. Part C. Calculate an estimate of the mean. This is the formula of mean. And mean, you can easily get mean by taking the sum of product of these things. 12 times this, 16 times 7.5, 32 times 15.5, and so on, divided by total frequency, which is 150. This is the answer of mean. Next question, number 6. Find the total number of different arrangements of the 11 letters in the word caterpillar. In this word, there are 2 A's, 2 L's, and 2 R's. When you will arrange all 11 letters, then you need to divide 11 factorial by the repetition, the factorial of the repeated letters. These are the number of ways. Part B. Find the total number of different arrangements of the 11 letters in the word caterpillar in which there is an R at the beginning and an R at the end and the 2 A's are not together. This question is very important. You can do this question in this way. First, find the arrangements in which R's at the ends, R at ends, and A's together. And then subtract the result of this from total. Total means R's at ends and the rest of the letters are random. So this is the total. And this is together, like R's at ends and A's together. So you need to subtract this from this total. Now, let's see how to get these number of arrangements, R's at ends and A's together. See, R's are here and A's are together. Now you need to arrange the remaining 7 letters at random. So these 7 and this one object will make 8 objects. One object, second, third, fourth, fifth, sixth, 7, 8. So 8 factorial divided by 2 factorial for 2 L's. Remember, this 2 factorial is for 2 L's. So these are the arrangements when R's at ends and A's together. Now, these are the arrangements in which R's at ends and the rest of the letters are at random. So there are 9 letters. So 9 factorial divided by 2 factorial for 2 A's and 2 factorial for 2 L's. This is total. This is R's at ends and A's together. You need to subtract this from this to get this requirement. Total minus A's together. So this is these are the number of ways of these restrictions. You can take the screenshot of this solution if you want, because this part is very important. Last part of this question, find the total number of different selections of 6 letters from the 11 letters of the word caterpillar that contain both R's and at least one A and at least one L. Now you need to make the separate selections, like you need to make the all possible selections. So 2 R's, 1 A, 1 L. Remaining letters are 5. Altogether we need 6 letters, so 5C2. Because you need 2 more letters from remaining 5 letters, so 5C2, 10. Now arrange selections with 2 R's, 1 A and 2 L's. Now you need 1 more letter from remaining 5, so therefore 5C1. Now these are the selections with 2 R, 2 A's and 1 L. We need just 1 more letter from remaining 5, so 5C1. Now selections with 2 R's, 2 A's and 2 L's, so 5C0, which is 1. Or you can just write this is just one selection. So get the total of these, which is 21. There are 21 ways for the selection of 6 letters with these restrictions. This is the last question of this paper, number 7. There are 400 students at a school in a certain country. Each student was asked whether they preferred swimming, cycling, or running, and the results are given in this table. Get the total of these numbers, horizontal totals and vertical totals. This is very important. A student is chosen at random. Find the probability that the student prefers swimming. So there are 135 students who prefer swimming. So 135 divided by 400. That's the answer. Part 2. Determine whether the events the student is male and the student prefers swimming are independent. This is the condition for independent events. This must verify if events are independent. So males, there are 180 males. So 180 divided by 400 is here. Swimmers, there are 135 swimmers divided by 400, and the common of these two is 31. Males and swimmers, 31 upon 400. This equation is not verified. Therefore, events are not independent. Must mention this equation first and then substitute the values. And then give the statement with respect to the answer. On average, at all the schools in this country, 30% of the students do not like any sports. Part B1. 10 of the students from this country are chosen at random. This situation is of binomial distribution with n 10 and p 0.3. Find the probability that at least 3 of these students do not like any sports. At least 3 means 1 minus 0, 1 or 2. With the help of binomial distribution formula, you can easily get this probability and give your answer up to 3 significant figures. Part 2. 90 students from this country are now chosen at random. This is the normal approximation because n is greater than 30. Find the probability that fewer than 32 of them do not like any sports. Fewer than 30 means less than 30. Fewer than 32 means less than 32. So the first possible integer on number line must be 31. Since we are going on this side, therefore we have to take the upper bound of this number. So 31.5 should be here. This is NP and this is under root NPQ. When you will solve this, you will get this. We need this area. This is larger area, so this is 5. And the answer is 0.850. An important advice for me and for everyone, we should be well-mannered. Best of luck. And I am extremely thankful to Miss Maharosh who helped me to make this lecture. Indeed, she is an outstanding student. May Allah Pak bless her always. Ameen. May Allah Pak give her the best grades. Ameen. Allah Hafiz.